Hello and welcome to this Python tutorial. In the previous tutorials we did the first steps of making our simple linear regression model, and those included the data preprocessing step, then fitting simple linear regression to the training set, which is where our model learned the correlations to make the future predictions, and then speaking of predictions as the third step, we predicted the test set results, and now we are finally getting to the fun part, which is to visualize the training set and the test set results. So that means that we're going to plot our observation points as well as the simple linear regression line to see how there is this linear dependency and to see how the predictions of the simple linear model can be close to the real observations. So let's do this. Let's plot these graphs and let's interpret the results. Okay, so generally to plot a graph in Python, we're going to use this matplotlib pyplot library that we imported as an essential library in the preprocessing step. So it's already imported. That's great. We're ready to start plotting our graphs. So the first thing that we're going to do is to plot the real observation points, that is the employees of the company characterized by their number of years experience and their salary. That means that on the x-axis we will have the number of years of experience, and on the y-axis we'll have the salary. So let's do this. It's actually quite simple. We need to use plt.scatter, which is a function of pyplot that will make a scatter plot of the observation points of your dataset. So you'll see it's actually quite simple. We just need to type plt.scatter. Then in parentheses we first need to input the x coordinate of your observation point, so that's xtrain, because first we're starting with the training set, xtrain, so that's actually the x coordinate of our observation points, because xtrain contains the number of years of experience, as you can see. These are the number of years of experience in xtrain. And now what will be the y coordinate? Well, the y coordinate will be the real salaries that the employees have in the company, and of course this is the salaries contained in the y-train vector. If we look at y-train here, these are the real salaries of our observation points, that is of our employees in the company. So okay, that will be y-train. And then since we'll plot the observation points and also the regression line, it would be better to colorize in different colors those two entities, like the observation points in one color and the regression line in another color. So that's as you prefer. Generally what I like to choose is to colorize the observation points in red and the regression line in blue. So here I'll just choose color equals red. Alright, and that will plot all the observation points, the real values. And now what we're going to do is to plot the regression line, that is the predictions. So here we're not going to choose plt.scatter because we're not making a scatter plot of the points. We will use simply plt.plot. And then as usual in plt.plot we will first enter the x coordinate of the points in the regression line and the y coordinate. So the x coordinate will be xtrain as well, because to plot a line we just need some x coordinates of the line, and then we'll specify what the y coordinates are. And speaking of y coordinates, what do you think the y coordinates of this regression line will be? Well, it will be the predictions of the xtrain numbers of years of experience, and the predictions of these numbers of years of experience in the training set in xtrain are the predicted salaries of the xtrain observations. So then be careful, it's not ypred, because ypred are the predicted salaries of the test set observations. Here we have test set. But what we only need to do is to just take this and copy this and then paste it here. And here we'll just need to replace xtest by xtrain, because we want the predictions of the training set and not the test set. Because here, we want to compare the real salaries to the predicted salaries, but based on the same observations, that is the observations of the training set. Okay, so then we have our x coordinate and our y coordinate of the regression line, and now what do we need? A color. Yes, because we want to make the distinction between the observation points above and our regression line. So since we chose red for the observation points, here we'll choose blue. Or you can choose whatever you want. That's just my personal preference, but you're welcome to try something different. And here it is. This second line plots the simple linear regression fitting line to our training set. Okay. Now we'll just improve our plot by giving a title, a label of the x-axis, a label to the y-axis, and it will be ready. So let's do this. Let's add a title. It's plt.title. Let's give salary vs experience, because we want to see the relationship between the salary and the experience. And here let's just add training set in parentheses to specify that we're plotting the training set results, because then we'll do the same for the test set results. So just to make the distinction. And that's it for the title. Great. Now let's add a label to the x-axis. So to do this, we just need to add the command plt.xlabel. And then let's call our x-axis years of experience, because on the x-axis are the numbers of years of experience. So years of experience. Here it is. Great. And now same for the y-axis. So this time it's going to be plt.ylabel. And then parenthesis salary. All right. Great. And then we just need to add a final line. It's plt.show with parentheses. And that's to specify that it's the end of the graph and that we're ready to plot it. Okay, so now it should be good. We have our observation points thanks to plt.scatter. We have our regression line thanks to plt.plot. We have a title, labels to our axis. So it should be all fine. Let's try. Let's try to select this and execute. Press Command and Control plus Enter to execute. And here is our graph. Great. Let's enlarge this. All right. So, okay, the first really important distinction to understand is that we need to make the distinction between the real values and the predicted values. So the real values are our red observation points, all these red points here. These contain the real values of our employees, that is, okay, their years of experience, but then their real salary, the salary they really have in the company. And then the predicted values are on this blue simple linear regression line. And by predicted values, I mean the predicted salaries, which are the projections of the points of this line to the y-axis. So for example, if we take this observation point here, that corresponds to an employee that has 4 years of experience and a salary about 55,000. So that's its real salary. But then to get the predicted salary of this employee, we need to first project this point on the regression line and then project again to the y-axis to get the predicted salary, which is then 60,000. So for this observation point, the real value for its salary is 55,000 and the predicted value for its salary is 60,000. So that's the first really important distinction to make. Now, what's interesting to see is that there is clearly a linear dependency between the salary and the years of experience, because as we can see, our regression line is approaching quite well all our observation points. You know, if we had some points everywhere, then our regression model could fit a straight line, but it would be far from our observation points. But here, since it's approaching quite well the points, then that means that there is linear dependency, and that's why we could fit a good simple linear regression model that gives good predictions. And speaking of predictions, we have some accurate predictions. For example, this one, we can see that the real salary is close to the predicted salary. This one too. This one is a very accurate prediction. The prediction is almost perfect. And this one as well. And then of course we have some less accurate predictions, because this is not a 100% linear dependency. So of course, for example, this real salary here is further from the predicted salary, which is here. So here, as you can see, that's the predicted salary for this particular employee, and that's the real salary. And same for this employee, and this one as well, this one as well. And now the third thing that is actually important and that we have to keep in mind each time we make a model is that these are the observations of the training set. So these are the results of our simple linear regression model, but which was trained on all these red points here, on all these red observation points here. So let's see how this simple linear regression blue line can approach new observations. And these new observations will actually be the test set observations. These are new observations because our model didn't learn on these test set observations. So what we will do next is we will plot the same kind of graph. We will keep this blue regression line because this is the regression line that was trained on the training set, so we don't want to change that. However, we will plot some new red points here because here these are the training set observation points, and we will plot in the second graph the test set observation points. So let's do this and let's see how our simple linear regression line can predict some new observations. So what we'll do is we'll copy this actually and paste it here because you'll see that we will only have a few things to change. Okay, so first let's change the section title here and specify that we're now visualizing the test set results. Okay, and here let's specify also in the title of the plot that we're now plotting the test set results. Great. And now what do we need to choose? Okay, so in the first line is plt.scatter that plots our observation points. And now since we are interested in looking at the observation points of the test set, here it won't be xtrain and ytrain, it will be xtest and ytest, because xtest and ytest are the coordinates of the observation points of the test set. And then, something very important to understand here. Do you think that in the second line, plt.plot, do you think we need to change xtrain here and here by xtest? And the answer is no, because our regressor is already trained on the training set, so whether we keep here the training set or replace by test set, we will obtain the same simple linear regression line. Indeed, if we replaced here xtrain by xtest, we would just build some new points of the same regression line corresponding to the new predictions of the test set observation points, because when we trained our simple linear regressor on the training set, we obtained one unique model equation, which is the simple linear equation itself. And therefore, whether we build the regression line here by predicting the training set points or the test set points, well, since these predictions result from the same unique simple linear equation, we will get the same regression line. So actually this is ready now. We are ready to plot the test set results. So let's do this. I'll select this and press Command and Control plus Enter to execute. And here are the test set results. So let's enlarge this. Okay, so these are the test set results. So be careful, this blue regression line is the blue regression line that we had in our previous plot in the training set results. So that's the same line because that's our simple linear regression model trained on the training set. But then these red points here are new points. These are the observation points of the test set, whereas before it was the observation points of the training set. So it's important to understand all this. And now let's interpret and let's give the final verdict. Well, this is actually really good because these are new observations and our simple linear regression model is making some very good job at predicting those new employee salaries. Because for example, if we take this one, it's clearly on the simple linear regression line. So the predicted salary is the same as the real salary because the red point is on the line. Same for this one, very accurate prediction, and same for this one, and this one as well. And of course, since there is no 100% linear dependency between the salary and the years of experience, there is of course some less accurate predictions like these two, and this one, and maybe a little bit this one. But overall, that's great. we made a good simple linear regression model that is perfectly able to predict new observations thanks to this linear dependency between the salary and their years of experience. Alright, so thank you for watching these tutorials and congratulations for making your very first machine learning model. So keep in mind, the machine here is the simple linear regression model, and learning means that we trained this simple linear regression machine model on the training set. That means that it learned the correlations of the training set to be able to make some future predictions. And so these are the predictions of the test sets, but we could make some new predictions with some new employees having other years of experience, and that would give us some great prediction of its salary, even if it was not in the original dataset observation point. So thank you very much for watching this tutorial. I hope you enjoyed what you learned, and I look forward to seeing you in the next section. Well, first we'll do the same simple linear regression model on R, and then we'll move on to the next level, which will be the multiple linear regression model, where we'll add some new dimensions, because this time there will not only be one independent variable, there will be several independent variables, and we'll learn how to deal with that. So thank you very much, and until next